Welcome to Notes 8.04. Getting started, today we're looking at the relationship between the sine function and the cosine function. Now those words are very similar, sine and cosine. There's only that C-O, kind of labeled in front of cosine. We're going to see what that means here in a minute. So looking at the triangle given, we have a person at A, a person at B, and right angle C. There's 15 as the length from B to C. BA is 40, and AC is going to be a side we're going to look for here for part A. So find the length of AC. We have x squared plus 15 squared equals 40 squared. It's going to be the most direct method to find that third side. So remember, we're working with right triangles. We can use the Pythagorean theorem. I could have set up a trig function, but it's just a little bit more involved. So from here, x squared plus 225 equals 1600. Subtract your 225 over, and we get x squared equals, and I've double checked this in my calculator, 1375. So from here, to get x alone, we take the square root of both sides. X approximates to 37.080. And rereading back through the question, and please make sure you're doing this as I found a lot of homeworks are being rounded incorrectly. It did say to the nearest integer, so we're going to eliminate our decimals, and we're going to have side AC represented by 37. Part B, we're going to fill in the ratios. So we just want the opposite to hypotenuse for sine and adjacent to hypotenuse for cosine. So sine from angle A. So if we fixate on angle A for a second, sine is opposite over hypotenuse. So opposite it is 15. The hypotenuse is 40. Looking at cosine from B. I'm sorry, cosine of A. Stick with angle A for 1 second. Our adjacent side is 37. Our hypotenuse is still a measure of 40. So those ratios so far are different because we're focused on the same angle from A. The next two, we're going to focus on angle at B. So sine of B, which is our 68-degree angle, okay? Its opposite side would be 37, and its hypotenuse is still 40. Now cosine from B is the adjacent over the hypotenuse. So the adjacent side there, so again, this isn't our adjacent anymore, that's when we were looking at A, but our adjacent is 15, our hypotenuse is 40. So remember, when you jump from one angle to the other within a triangle, your opposite and your adjacent flip-flop. And what that tells you is that sine from angle B's ratio, 15 over 40, is equal to cosine from angle B. Because when you focus on a different angle, the adjacent and the opposite flip-flop. So they become the numerator for each case. And I'm also going to look at those decimal equivalents. So sine from angle A, which is 22, sine of 22 equals 0.3746. Cosine from B also is going to equal 3.46. So cosine of angle B, which is 68 degrees, gives you the same decimal equivalent. And that's going to be the common theme here. Now, if we flip-flop and did cosine of 22, that's going to equal a new ratio, which is the same as sine from 68. So the other case is that cosine from A equals sine from B. So here the rule is going to say if A and B are acute angles of a right triangle, then sine of angle A equals cosine angle B when the measure of angle A and the measure of angle B equal 90 degrees. So these are called co-functions, and their sum is complementary. So co-functions are complementary functions, where the sum of A and B must be 90. So again, 22 and 68 must add to 90 to keep our rule of 180 in the diagram. So from here, let's fill in some of these answers. So sine of 20 equals cosine from what angle measure? So if we type in sine of 20 into our calculator, and going on the rule we just looked at, A and B are 90 degrees. Looking here, if this is my angle A, we're trying to find the measure here, angle B. A and B have to add to 90. So 90 take away 20 gives us 70 degrees. So let's check cosine from 70. We get the same decimal equivalent, 0.3420. So the answer here is 70 degrees. Sine of 33 would equal cosine of minus 33 is going to be 57 degrees. So that pattern kind of forms here. Sine of 45 would equal cosine of 45. 45 and 45 add to 90. Here, when we take 90 subtract 55, I think you guys get that, the cosine 35. So if we tested that, again, sine of angle 55 degrees, again, is just a ratio, it's a decimal equivalent, equals cosine of 35 degrees. And those decimals, again, are equal. So moving down to the next rule section of how these questions come up, is that sine of any angle, x, might be an unknown, equals cosine of 90 subtract x. So you, again, subtract x from 90. And same goes in the opposite scenario. Cosine of x equals sine of 90 subtract x. Now how we're going to set these up is we're going to always look at addition instead of subtraction. So in order to find x here, we took x plus 31 equals 90. So again, we want to be thinking addition. It's going to be helpful to solve our equation. But the opposite of addition there, we reverse operations, that's where we're going to get our 59 degrees here. Exercise 4 is very similar. 75 plus x will equal 90. Subtract 75 over, x will equal 15. So those examples are very similar to that last section. But numbers 5 and 6 change a little bit, and we're going to have some extra practice with these on the next page. But looking at number 5, again, sine from one angle, let's say A, equals cosine from the other angle, B. Well, if we know angle B is 50, angle A must be 40, because those two angles, it's an equal sign, have to be complementary. So if we took a number minus 4, we need to gain 40. X will end up being 44. Some of you can see that in your head. Otherwise, we're going to stick with this equation. X minus 4 plus 50. So whatever's next to sine and whatever's next to cosine, add to make 90. And when we combine like terms, x plus 46, because negative 4 plus 50 is 46, equals 90. Subtract 46, and x is 4. And again, back in there, 44 minus 4 would give you sine of 40 would equal cosine of 50. So number 6 is where this equation is most helpful. We have sine of some number equals cosine of that number at 10, where these two numbers are complementary. So we're going to always take those two expressions, add them to equal 90. So 2x plus 10 is 90, subtract 10 over, 2x is 80, therefore x is 40. degrees. So that's the quick version of these notes. Looking to the back, there are some examples that try to confuse you as I ask these questions on the state exam. So in scalene triangle ABC, shown in the diagram below, angle C is the 90-degree angle. Which equation is always true? So this is a rule that if you kind of memorize it, you're golden every time. But sine from A can't equal sine from B unless it was an isosceles triangle for some reason. So if you always think about three sides of a triangle being, let's say, X, Y, and Z, those are three unknown measures. Sine of A would be opposite over hypotenuse, is Y over Z. Now those are some numbers being divided. Would sine of B be the same thing? So focusing on B, sine of B would be X over Z. Those can't be. So again, cos of A, cos of B, those two answers are so similar, they're not going to be the same answer. Cosine of A and sine of C. Now technically, with C being the right angle, we can't find the hypotenuse or an adjacent side from there. So sine of the right angle or cosine of the right angle is never going to be our answer. But our rule here, and that's really the title of our notes, is that sine A equals cosine from a different angle B. Moving down to the next example. Now this picture we can actually sketch out, and this is a strategy that we're going to come across in a few other of these more advanced questions in the next few classes worth of content. Cosine B equals 5 to 13. Now we know the 5 is the A and the 13 is the H. So if I draw a right triangle, C they tell you is 90, cos B starts here. So from B, I know my adjacent side is on the bottom and my hypotenuse is to the top. Well, they're telling me the adjacent side measure is 5 and the hypotenuse measure in the denominator there is 13. So you could actually draw out a triangle here, but what other function is going to equal 5 compared to 13? And that's going to be sine from angle A. So again, cos B and sine A are equal. That from angle A, it's not adjacent side, but its opposite side is 5. Sine from A has an opposite side of 5, and its hypotenuse is 13. So those fractions are equal when we focus on the opposite variable. Moving down to exercises 9, 10, and 11 are very similar to the end of the front page there. That sine of 60 degrees equals cosine of some number plus 10. So we know that these two measures, whatever's next to sine and whatever's next to cosine, should add to 90. They have to be complementary. So combining like terms, we have x plus 70 equals 90. Therefore, x would subtract over 70 gives you 20 degrees. So x is 20. In a right triangle, sine x equals cosine of x minus 40. Same case here. We're going to take x and x minus 40 must be complementary. Add to 90. So here we have 2x minus 40 equals 90. Be careful. You have to add 40 to both sides. Therefore, we have 2x equals 130, making x equal to 65. So that if we have sine of 65, and we type in cosine of 65 minus 40, those decimal equivalents are the same. And if this was a multiple choice question, like this is 1, 2, 3, 4, You could go through the choices and type them in as well to see when you have your decimals being equal. The last case, exercise 11, in a right triangle. So again, that's key piece here. Sine of 40 minus x and cosine of 3x are equal. What is the value of x? So here we're going to take 40 minus x plus 3x equals 90. Combine like terms. 40 plus 2x equals 90. Here we subtract 40 over instead of adding it, like the last question. 2x equals 50, and x is therefore 25. So that's the notes in a nutshell, pretty quick notes for today. But I would like to view a couple homework questions just to help you ladies and gents out. Looking at numbers 1 and 2 are kind of right based off of the notes we just did, so those should be pretty self-explanatory. I do want to look at exercise 3, and I've got to reset, bug me. Be careful with this one. It's not just ending in the value of x, like the last few examples we did. So for the acute angles in the right triangle, sine of 4x equals cosine of 3x plus 13. So very similar to those last few questions, we add those two measures up equal 90. Once you find the x value, make sure you sub back in. So I'm not going to finish this question. I'd like you to be handwriting this work out. Also, with that said, I would like to see these equations drawn out. So like number 1 is pretty self-explanatory. If you draw a picture and label your adjacent side, your hypotenuse. So here we have a picture. C is the right angle. A is here. Now remember, we have A over H. So the adjacent side to angle A here is the square root of 21, and its hypotenuse is the denominator is going to be 5. So that's how you can draw a picture from those words and symbols. What would sine of B be? Well, cosine A and sine B should be equal. Right over that. So that's a pretty easy example for the most part if you know the rule, but I would like you drawing out these pictures for the questions we have here on scrap sheet of paper or loose leaf paper. And if you could clearly indicate your answers, it's going to help me grade these fast and get them back to you so you're more prepared for your next assignments. Number 4 should be pretty self-explanatory. Number 5, a little hint here. When x is in the denominator, you're going to divide. Looking to the back page, those are really the questions I needed to focus on a little bit more. Here, we're finding the value of an angle. So remember, you might need that second sine or second cosine function for number 6. Number 7 is an explanation question based on the rule we just learned. The wording kind of did shift from one line to the next. So if you want to write in, that should say sin 28 equals hj over 20. And for exercise 8, you do need to be finding here, and I'm just going to highlight this, DC and BC. So if you put across DC and they gave you that this was a rectangle, right angle, and X there, you're going to set up one trig function from the 30-degree angle. You have its opposite side and its hypotenuse in this right triangle here. So you'll have sine of 30 equals x over 12. But then you're also going to need to find BC. So from B to C is going to be y. So you're going to set up another trig function here from that angle of 30 degrees. The last part of this question is to find the perimeter of the rectangle to the nearest tenth. So remember, perimeter is the sum of sides. I don't know if you heard my little guy knocking on the door. Time for me to go. Good luck with everything. Thank you.